Okay, we're going to be talking about the binomial series here. And notice that it says that in the binomial series, x has to be between -1 and 1. So what are we talking about when we talk about binomial series? Well, we're talking about this 1 plus x to the power m, where m can be, any power. And this series is set up by saying, well, you just have 1 plus the sum from k equal 1 to infinity of what's called m choose k times x to the k. Now this part right here, m choose k, is probably something that's new to you. This right here is what we call a combination. All right, so a combination. And what exactly is a combination? Well, a combination is a set of ordered numbers, a set of ordered objects. All right, the arrangements that you can make with a set of numbers or objects. All right, and the order here does not matter. All right, so let's say you had an arrangement of letters, suppose AB. Well, the combination BA is the same as AB. All right, the order does not matter. All right, the order doesn't matter there. So there is a way to calculate this, m choose k, and we're going to take a look at the formula that will help you set this up, but otherwise you just follow each successive step, and we'll see in some examples here what we're talking about. So let's suppose that you had m choose 1. Well, there's only m ways to do that, okay? If you said m choose 2, then you'd have m times m minus 1 over 2 factorial, okay? And if you were to suppose, and I'll write it here off to the side, if you wanted to do m choose 3, all right, what would that look like? Well, that would look like m times m minus 1 times m minus 2 divided by 3 factorial. Well, what does that look like in general? M choose k. You have m times m minus 1 times m minus 2, and so forth and so on, such that you would have m minus k plus 1 over k factorial. All right, and this is, of course, for k's that are greater than or equal to 3. All right, so this is the way that the binomial series is set up, and what we're going to do here in a few examples is we're going to learn how to do this in the first example, but then I'm going to show you a trick of sorts to help you do this rather quickly, because when you see the process involved, it's actually quite lengthy, but there's a trick really, and you're going to see that it's actually quite cool. So let's go ahead and take a look here at the binomial series. All right. Okay, so here is the first example in finding a binomial series for a function. Suppose we had 1 plus x quantity to the 4th power. What would this look like? Well, we know the first element is going to be 1, all right, based on the setup here that we were given. All right, the first element is going to be 1. All right, and then what we're going to do is we're going to write each of the elements of the series itself. So 1 plus, and then we're going to say, well, we have m choose 1. In our case, m, the power, is going to be 4. So we're going to say 4 choose 1, and then times an initial x plus 4 choose 2, all right, and then x squared. So it will follow the value of k here, because that's what the series looks like. All right, plus, now we're on our, let's see, we started off with 0, 1, 2. We're on our third step here. We're going to say 4 choose 3, and then we're going to write, of course, x cubed, plus, now we know this is going to be our last step, because we're going to have 4 choose 4. All right, and 4 choose 4 will be multiplied by x to the 4th power. All right, so that's what this right here would look like. All right, now what we're going to do is we're going to do the combinations here, and this is a part of a branch of mathematics called combinatorics. All right, and often in a probability and statistics course, this is definitely a topic that's discussed, but we're talking about it here in terms of sequence and series, because it's applicable to the binomial series here. All right, so let's go ahead and do the math, if you will. And we're going to use these formulas here to help us out. So what does this look like? This is 1. Now, for 4 choose 1, I'm just going to put, okay, 4 choose 1. All right, that is just 4 itself if you follow this formula. Okay, I'm not going to explain that one. What I will explain are the subsequent ones. So 4 choose 2 and so forth and so on. So 4 choose 1 is just going to be 4x. All right, you kind of have to know that one. But then 4 choose 2 is going to be 4 times 4 minus 1 divided by 2 factorial multiplied by x squared plus, and then 4 choose 3 is going to be 4 times 4 minus 1 times 4 minus 2 over 3 factorial. And then, of course, x cubed. All right. And then our last step here is going to be 4 choose 4. So that's going to be 4 times 4 minus 1 times 4 minus 2 times 4 minus 3, all divided by 4 factorial. Okay. Multiplied by x to the 4th power. And now we're going to simplify. So what does this look like? 1 plus 4x. Now 4 times 4 minus 1, this is 4 times 3, which is 12 divided by 2 factorial, and 2 factorial is just 2 times 1. All right, so 4 times 3 is 12, really divided by 2, that's going to give me a 6x squared. Okay, now looking at the next part, we have 4 times 4 minus 1, well, that's 3. 4 minus 2, 2. 3 factorial is 3 times 2. So what ends up happening here is that you actually get rid of this. All right, leaving you with 4. And then it's going to be x cubed. All right, and then you continue. You have 4 times 4 minus 1. This is 3. 4 minus 2 is 2. 4 minus 3 is 1. 4 factorial is 4 times 3 times 2 times 1. What ends up happening is this crosses itself out with all of this, leaving you with a 1 as coefficient, x to the 4th power. And this right here is the binomial series for 1 plus x to the 4th, but it is also the binomial expansion of it. Okay? So that right there is what you would get. Now, I want you to notice something about the coefficients. 1, 4, 6, 4, and 1. All right. What I'm going to do is I'm going to point out something. All right. I'm going to point out something, and there's an interesting thing going on here. So let's switch colors here. Suppose that I had some binomial a plus b to the 0 power. All right, well, what would that look like? That would just be a 1. Suppose I had a plus b to the 1st power. Well, what would that look like? That would be a plus b. What if I had a plus b to the 2nd, a binomial squared? Now, this one, if you are a student in my class, I've been harping on this all year. The binomial squared is simply a square plus 2ab plus b square. Okay, but what if you move higher? A plus b cubed. Well, there's actually a trick to this. This is the a plus b times the a plus b squared. What you end up getting here is a plus b, a cube, plus 3a squared b plus 3ab square plus b cube. All right, so what I'm getting at here is that the powers need to add up to equal the highest degree, and that is that if you are squaring it, for example, then the highest power should be a 2, and the power of each element should add up to equal 2. So notice This is a squared, so we have a second power. This is a times b. This is a to the first and b to the first. 1 and 1 is 2. And then this right here gives you your 2. So each element has a second power. Looking at the third order, we have, of course, a cubed because the first element is cubed, right? So then you have a cubed, and then you have a 3. You have a squared b, so this is 2 and 1. That right there gives you your order 3. Then you have 3ab squared, so that's 1 and 2. That gives you your order 3. And then b cubed gives you your order 3 as well. So I'm going to move on, and I'm going to write out the very last one here because we can go on and on and on. But let's say we have a to the 4th power. Then we're going to have 4, and then a drops by 1 power, a cube plus, I'm sorry, not plus, a cube b, 3 plus 1 has to equal 4, plus 6 a squared b squared. Again, a drops by 1, but b increases by 1. 2 plus 2 is 4, so we're still at the 4th order there. Plus 4, okay? And then you have a dropping by 1 and b increasing by 1, so ab cubed, plus now 1, all right, which is a b, and then it's going to be b to the 4th because a drops by 1 and b increases by 1. So I want you to see a pattern here. That is that I start off with 1, and then I have 1 and 1 for the a and the b, and then I have 1, 2, 1 for the a squared 2ab plus b squared, and then I want you to see the next part. I have 1, 3, 3, 1, and then I have 1, 4, 6, 4, 1. So watch this really neat. 1 and 1, there's only one way to get to 1. 1 to 1, there's only one way to get to 1. To get to 2, okay, there's 2 ways to get to 2. All right, you have that way and you have that way. 1 and 1 is 1, okay. Again, there's still only one way to get to 1, but there are now 3 ways to get to that number there. So think about it. What do I mean by 3 ways? All right, let me line that out in a different, maybe highlighter here. There's one way. That's one way. All right, that's 2 ways. All right, and then that's 1, 2, that's the 3rd way. Okay, so there is a pattern in all of this, and this is actually building up to something even greater. So what I want you to notice is that if you see here, of course, one way to get to 1, 1 and 3 gives me 4, 3 and 3 gives me 6, 3 and 1 gives me 4, and then again, one way to get to 1. All right. So you can determine the rest of the numbers here based on what you see here. So we can actually figure out the rest of this. I mean, I can add another row in here. I know this is going to be 1. This right here is going to give me a 5. This is going to give me a 10. This is going to give me a 10. This is going to give me a 5. And then this is again going to be a 1. And you're going to see it in play here. All right. There you go. And you can keep going. This right here is what we call Pascal's triangle. So let me go ahead and move that triangle in for you. Give me 1 second. All right. So if you see this triangle that I've laid out for you, all right, this right here corresponds to the coefficients for any really binomial to any power, any whole numbered power anyways. So knowing this trick, all right, we're going to make use of this triangle. And again, this is called Pascal's triangle. So let me write that out here for you. And it's really neat because it applies here to this binomial theorem and really to this binomial series that we're working with. Now we're looking at a binomial series with a 1 plus some power of x. Okay, but this will work for any binomial. All right, this will work for any binomial, so it's actually really neat what we're doing here. All right, and I think it deserves some appreciation because of the way that this works out. Now, there is a connection between Pascal's triangle and what are called the Fibonacci numbers. I'm not going to get into that in this video, but something to think about and maybe something that you might want to research. All right, but let's take a look at another one. Here we have 1 plus x squared to the third power. So when I look at this, something to the third power, I know I'm going to be looking at the third row. So I'm looking at these numbers here to serve as my coefficient. Okay, my coefficients for my binomial expansion here. So what I'm going to do is I'm going to write 1. I'm going to write a parenthesis plus 3, a parenthesis, plus another 3, and a parenthesis, and a 1, and then another parenthesis. All right, and it's up to us to figure out what goes inside there. So we know that it has to be order 3. All right, it has to be order 3. So in this case, we actually do not need these extra sets of parentheses here, because this right here is just the simple 1 to the third. All right, so this is not needed, and neither are these, all right, for that matter, except for the fact that you do need right here. You actually do need this. I'm sorry. I'll show you what I mean. All right, you have a coefficient of 1, but then you have your initial a term. All right, so let me write it out. I guess I suppose I'll write it out. Should be 1a cubed plus, in this case, it is going to be 3a squared, because the a drops by a power, b, plus 3ab squared plus 1b cubed. There we go. There we have it. So this is a and this is b, and we're going to plug in what we know. So we know then that this is going to be squared, this is going to be cubed, this one is going to be to the first power, this is now going to be to the first power, and this to the second power, and this is going to be cubed. And then we're going to fill in our a's and our b's. All right, so let's see here. This is a 1. All right, this is a 1, this is an x squared, this is a 1, this is an x squared, and then this is just going to be an x squared because we do not need the 1's there. All right, so what are we looking at here? Well, 1 times 1 cubed, that's just 1. Plus 3 times 1 squared, that's 3x squared. So 3x squared plus 3 times 1 to the first is just 3 times x squared squared, that's 3, and then followed by an x to the fourth, plus a 1, we don't need to write it, but x to the 2 times 3, x to the 6th power. All right, and that's what that looks like right there. So it's actually really neat. All right, and we're going to look at a couple more examples, and they're all, ironically enough, to the third power. So we've got this same setup here that we're going to be using. All right, so we're going to use that in problem number 3 and then problem number 4. So we're going to say this problem number 3 is 1 minus 2x quantity cubed. So let's go ahead and fill that in as best as we can. So we're going to write this cubed plus 3 parenthesis square parenthesis, right? Plus 3 parenthesis squared plus a parenthesis cubed. All right, and this of course is a and b, and we're going to fill in what we know. 1, 1, negative 2x, 1, negative 2x, and then negative 2x. And when we simplify, what do we get? We get a 1. We get 1 squared, which is 1. 3 times 1 is 3 times a negative 2x is a negative 6x. Negative 2x quantity squared is a positive 4x squared times 3 That's a 12x squared. All right, and then a negative 2x to the third power is going to give us a negative 8x cubed. And that right there is the binomial expansion for that. All right, so as you can see, we're doing this rather quickly. All right, we're doing this rather quickly. So let's go ahead and take a look at one last example here. And this one might be a little more tedious, but it's actually not that bad. If you followed along so far, you're going to be good at these binomial series. So let's see here. We've got something cubed plus 3 parenthesis squared parenthesis. Notice I'm following the same pattern. Plus a 3 parenthesis parenthesis square plus a parenthesis cube. And we fill in our A and our B. That's a 1, a 6x squared, a 1, a 6x squared, and a 6x squared. What does this look like for us? 1, 3 times 1 squared is 3 times 6x squared is an 18x squared. 6x squared is a 36x to the fourth times 3. 36 times 3, 108. So we have here 108x to the fourth power. Plus, now our last term here is 6x squared cubed. So 6 cubed is 216. So that's 216. And then we have x squared to the third power, which is going to be x to the sixth power. All right, when you raise a power to a power, remember you multiply. So this right here is our binomial expansion for that. So I'm going to take it back just a little bit, just so you can reflect on how easy you have it now with Pascal's triangle. This again works for any binomial. It does not have to be 1 plus or 1 minus for that matter. But what was it based off of? Well, we're talking about the combinations, the possible combinations of those coefficients here. And that's where this is getting at, okay? So the Pascal's triangle really makes things nice, because otherwise we have to do all this work. And look how we just breezed through, because we knew some patterns based on numbers present on this triangle that was made famous by somebody, a mathematician by the name of Blaise Pascal. However, I believe that it was a gentleman I believe his name was Yangtze. I believe he was from China, that predated Pascal, that actually came up with it first. You can do your research on that. But Pascal just was more famous, and that's why he's given the credit. And that's typically what happened in the world of mathematics. But as always, I hope this video was helpful. And remember, like and subscribe.